So hello geometry class. Today we are going to learn about section 11.4, three-dimensional figures. That's on page number 329 to 332 from Big Idea Student Journal. Here basically we are going to learn about classifying the solids, cross sections, solids of revolution and axis of revolution. These are the basic things we are going to learn. So let's move to our first definition. Before we even start classifying the solid, we have to talk about what is solid. Solid is basically, it's a three-dimensional figure where you see it's in three dimension. It has length and its width and height, like any object you see surrounding you, and it's a solid object and it has bounded by a flat or curved surfaces. You will see anything around you, these are all solid things. But out of those solid things, there is one thing that is called polyhedron. What is that? Polyhedron is a solid that is bounded by polygons called faces and edge. So basically, when you look at polyhedron, it won't have a curved surface around it. You will see flat surfaces around it. So that's called polyhedron, and polyhedron has an edge. So suppose this one is a polyhedron here. It's an example of a polyhedron, and in that case you see it has how many faces? This is one face, two, three, bottom one, three, four, left one, and five is the back one, this one. So it has five faces that you have to imagine. Like if there is a solid, how many flat sides you see of this? That's a face. And the edge is the corner, this one, this is the edge, this is the edge. All the line segments you see around, they're all the edge, and this one is the edge, this is the edge, this is the edge. They're all three one are behind because it's a 3D, you can see it. And then other definition is about the vertex. So here vertex is basically what? Vertex is the point where the two edges meet. This is the vertex, this is the vertex, 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 and there is one more which is, you can imagine it is in the back of the solid. So these are the vertex. So where the three edge or two edges they meet, that's the vertex. And then three or more, and plural of polyhedra is polyhedrons. All right, if you have more than one polyhedra, it's polyhedron. So let's move to this specific kind of solid. We are going to analyze a few things. So this is not working with a partner. So basically these are five platonic solids. So these are tetrahedron, this is cube, octahedron, dodecahedron, and icosahedron. What I would like you to do, you can stop the video here and try to explore for tetrahedron how many vertices, and just write down the number here, then how many edges and how many faces. So just try to enter the information, then match with mine. I'm providing you the answers. So like so you can stop if you want. So if I talk about very first one here, the tetrahedron, the vertices, how many vertices? It has one. This is the second one, third, and fourth. Do you see any other vertices? No. So this has four vertices. If I have to talk about edges, how many edges are there? One, two. So let me first erase all, so I just show you the edges. If I have to talk about edges, 1, 2, 3, 4, 5. Do you see any other? Yes, this is the one which is behind in the back. So they made it dotted because it's not visible. So that is 6. Let's talk about next thing. We have to talk about faces. How many flat surfaces you see? So when we talk about the flat surfaces, I see this is one flat surface here. Then I have this one flat surface here, other flat surface here, and this is the bottom one. So I have 3 on the sides and 1 on the bottom. So it means I have 4. Same way I'll do one for cube. cube has how many flat surfaces? Just like a die or something, you see that. So you have how many vertices? It has 1 2 3 4 5 6 7, and this is 8. It has 8 vertices. How many edges? It has 1 2 3 4. Same way on the back, 1 2 3 4, and then so 8, now 9 10 11 12. It has 12 edges. If I talk about faces, you can always look around your, it's just like if you imagine your room is like a cube, and how many flat surfaces you see? You see 4 walls and you see top and bottom. So it has how many? 6. Same way when you try to do octahedron, dodecahedron and icosahedron, your answers are going to be, I'm providing you the answer, try to explore and match it. 6 12 8, and here it's going to be 20 30 and 12. This is 12 30 20. All right, let's move to the next part. Types of solid. So we have 2 types of solids here. 2 types of solid. We are talking about polyhedra especially. So we are going to classify, few solids are going to be polyhedra and few are not going to be polyhedra. So how to know? Polyhedra has flat surfaces, doesn't have a curvy one. So this prism is a polyhedra. You see there is no curvy surface here, no curvy surface. You see only flat surfaces, and here also this is a polyhedra. But when you talk about the not polyhedra, cylinder, cone and sphere, they are going to be not polyhedra because it doesn't have, it has a curvy surface. It has curvy surface. All right, let's move to next part. Describing cross section. Cross section is just like if you're cutting an apple, you just slice it through the middle, and what kind of shape you see after slicing the inside part, that is called a cross section. So slicing through a solid, that's the intersection of the plane and the solid, is called cross section. The shape you see, that's called cross section. If you have a, this is your cube, all 3 cases are cube, and they're showing that you slice in 3 different ways. If you're just slicing it like horizontally, then when you slice it, slices horizontally. Let me use different colors. So this is the one, and what is the shape when you slice it? This is the shape you see, it's the square. When again you slice it diagonally like that, then you see this shape, that's called what? That's a rectangle here. You see a rectangle when you slice it through the diagonally. What if again you slice it from the corner? In that case your shape is going to be like a triangle. So the shape of the cross sections depend on how you slice through the solid. So let's move to the next part. Sketching and describing solids of revolution. So solid is of revolution is basically you have to think that you are given some shape and you have to revolve it around 2-dimensional shape across some kind of axis, and then you have to imagine, is there any kind of solid forming, like so solid of revolution is a 3-dimensional figure that is formed by rotating a 2-dimensional shape, and the line across which it is rotated, it is called axis of revolution. So let me show you. So if you imagine you have this rectangle here, and you keep on rotating this rectangle all around, and you come back to the original position. You see that when you rotate it little bit, you imagine it's rotating and that whole space is covering with some solid thing. So as you keep on rotating, this comes back here, and what you see now? You see it is forming a cylinder. So that's called solid of revolution. This solid cylinder is, this is a solid of revolution. It's solid of revolution, and what kind of solid is formed? That's called cylinder. All right, and the axis across which it is rotated, that's called axis of revolution. All right, So that you have to figure out. Could be any axis, x or y, anything. All right, so let's move to another example. Another example we have been given here. We suppose this is the figure for yourself, and then I say, okay, just rotate this triangle, and what kind of solid is formed if I'm just rotating any direction. Suppose if I'm rotating it counterclockwise, it's going like this all around and coming back here. So that's my direction of rotation. So when I rotate it, you see it forms kind of, when I fill inside the space, all the area covered or space covered by this triangle, that becomes a cone with the same height and with the same radius. You see the height is 6, that's the same here, height is 6, and then the radius is 4 of the triangle, so the base is 4, that becomes the radius of the cone here. So I hope you get it. We're going to do more problems in the problem part of section 11.4. Till then, stay safe and thank you.